In our first lesson in Unit 1, we learned about pure substances versus mixtures. And one of the pure substances we talked about were elements, and the other one we talked about are compounds. And one of the reasons that a compound is a pure substance is because compounds never change. Okay, and for example, water, the chemical formula of water, that compound H2O, is always H2O, which represents 2 hydrogen atoms, 1 oxygen atom. Okay, in the chemical formula of sucrose, sucrose is the table sugar that you put on your cereal or whatever. There's always 12 carbon atoms, 22 hydrogen atoms, and 11 oxygen atoms. One of the things that we can do is we can take that molecule of, let's say, sugar, and we can figure out, okay, of that molecule that has the 12 carbons, 22 hydrogens, and 11 oxygens, what percent of that molecule is made up of carbon atoms? Okay, and the way that you do that is you find what's called the percent composition. Okay, the percent composition is exactly that. Taking the whole formula, what percent of that formula is of its mass is made up of carbon, and what percent of that mass is made up of hydrogen, what percent is made up of oxygen. Okay, now this is very similar to the when we talked about isotopes and we did that percent, the percentages, the percent abundance of each isotope. Remember that the percentages have to add up to 100%. So the percent of carbon's mass and hydrogens and oxygens all put together has to equal 100. So if you're asked about the percent composition, and again, sometimes they call it different things, but it all means the same thing. It means in that whole molecule, what percent of that mass is carbon, what percent is hydrogen or oxygen. Okay, so sometimes we call it the percent by mass composition, sometimes just percent by mass, or sometimes just percent composition. It all means the same thing. We're talking about the individual element in a compound. We divide by the total mass of each element of each element by the total mass of the compound. So it looks something like this. If we were doing this for sucrose, so remember the chemical formula of sucrose, C12H22O11. If we're doing that and we say, okay, what's the percent composition of carbon in sucrose? Well, then notice here on the top that we take the mass of carbon, which is from the periodic table. The molar mass of carbon is 12, and since there are 12, this 12 right here is the number that goes right here. And then on the bottom, and you don't have to show all of this, I'm just showing it for you the first time, is we get the mass of the entire molecule. So make sure to include that carbon again on the bottom, and then there's the mass of hydrogen times the number of hydrogen atoms, and then the mass of oxygen times the number of oxygen atoms. Okay, and make sure that you add all those numbers together. Remember your calculator, be very careful in that you need to get a number on the top, I believe it's 144. You need to get a number on the bottom, I believe it's like 342. I could have just made all that up, I don't really know. And then you multiply by 100. Check that on your calculator, see if you get the same answer as me. You should get a percent of carbon of 42.1%. So that means of that molecule, 42.1% of that mass is carbon. Okay, now could we do the same thing with hydrogen? Of course we could. How does this equation change though if we say what's the percentage of hydrogen? Does the mass of the entire molecule change? Of course not. It's still going to be 342. But now on the top, again, if we're doing this for hydrogen, we would put the mass of hydrogen on the top, which would be the 1 times 22, which would be 22. So then you take 22 divided by 342, then multiply by 100. Let's check what that would be. 22 divided by 342 times 100 equals 6.4, let's say 6.4%. Okay, and if you think about it, there's two ways we could figure out the oxygen part. We could say, okay, well, for oxygen, we've got the 6.4. So for oxygen, it's going to be the same thing. You're going to have 342 on the bottom. Oxygen, 16 times 11, 176. So then we could take 176, divide by 342, and we get times 100, 51.5%. Now, another way you could have done that is gone, well, wait a minute. If you take 42.1 and add 6.4, that's 48.5. And if there's only 3 elements in the compound, 100%, remember it has to add up to 100, 100% minus 48.5, big surprise, equals what? 51.5%. Okay, so example 1, determine the percent composition of hydrogen in acetic acid, which has the chemical formula of CH3COOH. Okay, so the first thing we're going to do is they want to know the percent composition or the percent by mass of hydrogen. So we're going to put the mass of hydrogen on the top. There's 3 hydrogens here plus 1 more. Don't forget that. That's an easy mistake to make is, well, which hydrogens? Well, certainly all of them. Okay, so there's 4 hydrogens and it has a mass of 1. So 1 times 4 is going to go on top. And again, you could just write 4. I'm just showing the whole thing. And then for the mass of the whole molecule, again, I'm going to show it, but you could just do it on a calculator. There's the hydrogen component, and then there are 2 carbons. And carbon has a mass of 12, so 12 times 2. And then for oxygen, there's 2 of them, so plus 16.0 times 2. Okay, so 1 times 4 is obviously 4. 4 plus 24 is 28. 28 plus 32 is 60. So 4 divided by 60 is going to be, and then we're going to multiply by 100 to get a percent. 4 divided by 60 times 100 equals 6.7% or 6.67%. Okay? And that is the percent of by mass. So again, the mass of that molecule is 60 grams per mole, or 60 atomic mass units. And of that 60 grams per mole, 4 of those grams are due to hydrogen. And so therefore that is a 6.7% of hydrogen. Okay, example 2. Which of the following compounds has a percent composition of oxygen of approximately 67%? Okay, so here's a multiple choice question where, well, I don't know what's the right answer is. Here it's really a guessing game, okay? 67% is about 2/3. So I'm just going to choose a random answer. I'm just going to start at A and say, okay, what is the mass of the oxygen component? Oh, I don't know. There's this negative. There's a negative. And there's a, what do we do with those negatives? Remember, the mass of the compound or the molecule does not depend on the electrons. So a negative charge or a positive charge has no effect on the overall mass because electrons weigh so much less than the protons and neutrons do. So the mass of oxygen is 16. There's 3 of them. That's 48. 48 plus 14 is 62. 48 divided by 62. If I get lucky right away, there's really no way to do this without just actually doing it. 48 divided by 62 times 100 is about 77%. Okay, so what does that tell me? Tells me, well, it's not A. Okay, let's go to, let's go to B, or let's go to C. Just because manganese, I don't know the mass of manganese off the top of my head. So on C, the mass of, again, the percent composition of oxygen is 32. The mass of the whole thing is 32 plus 1 nitrogen, which has a mass of 14, is 46. 32 divided by 46 times 100% is 69.6%. Not close enough. I don't like that enough to say that that's okay. Okay, SO4 2 minus. Again, forget about the 2 minus part. Oxygen has a mass of 64. 16 times 4 is 64. And then for the total mass, we've got the 4 oxygen, 64, plus sulfur, which is 32. That is 96. And again, we know it's not A and we know it's not C. We're getting unlucky here because we're just having to go through all of these. 64 divided by 96 times 100 is 66.7%. Rounded to a whole number, that would equal 67%. Okay, so the correct answer is D. Okay, now certainly B, you could go, and I just don't know manganese off the top of my head. I think it's like 52 or something like that, but I'm not entirely sure. So luckily the correct answer was D, so we're good. Okay, example 3. Which of the following compounds is approximately 50% oxygen and 50% sulfur by mass? Now again, in this case, it doesn't really matter Well, do I do oxygen or I do sulfur? Well, if oxygen's 50%, then of course sulfur has to be 50%. So this one's a little bit quicker than example 2, because right away you go, okay, well, oxygen's 16 and sulfur's 32. So if that's the case, I need them to be the same number so that they're each 50%. So here, for example, we would have 16 over 48. Well, of course that's not 50%. Okay, over here you'd have, again, just like the one above, 64 over 96. Remember, SO42 minus up here was 64 over 96. Okay, so we need one where the masses of the two in that compound are the same. So obviously on B, you've got oxygen. There's 2 of them, so that's a mass of 32. You divide by the total mass, which is with the sulfur, 64, times 100 equals 50%. And of course, the same mathematical equation applies if you do sulfur. Sulfur has a mass of 32. Divide by 64 equals 50%. Okay, and that is how you find percent composition.